We can recall from the last video that the more positive an E standard value is, the more spontaneous that process is. And so we can consider the spontaneity of each of these reactions written here. Which of these is more spontaneous? Lithium being reduced or fluorine being reduced? Well, which one has the more positive value? Lithium, to be reduced, has a negative 3.05 voltage, whereas as its standard reduction potential, but fluorine has a positive 2.87 voltage for its standard reduction potential. We can see that fluorine, having this more positive standard reduction potential, is more likely to be reduced. We can see that as we go up, as these values of our standard reduction potentials are increasing, we have an increasing ability to be reduced. We have an increasing strength as the oxidizing agent. And so, which of these compounds is a stronger oxidizing agent? Oxygen or iodine? You would say oxygen. It's higher up on the list. But we could try a problem. Which is the strongest oxidizing agent of all of these three things? Aluminum ion. Let's see, where is our aluminum ion? Here's aluminum ion. Aluminum, solid. Silver, ion. Or silver, solid. All right, so you know that higher up you have increasing strength as an oxidizing agent. So which of these is the strongest oxidizing agent then? Is it silver ion or silver? Well, silver ion, you see, can be reduced. It can accept an electron, and being reduced, it's an oxidizing agent. But what about silver solid? Can it be an oxidizing agent? Can it be reduced? Well, no. Silver solid being reduced, accepting an electron, that would give silver with a negative charge, which you know metals do not get. This reaction is impossible. Silver solid cannot be reduced. Silver solid is not an oxidizing agent. And so the best answer then is silver ion. That is the best oxidizing agent. Now we can also talk about strength as reducing agents. Now, in order to do that, we need to determine how likely it is something will be oxidized. Now, the reactions as they're currently written are not showing any oxidations, but instead are showing reductions, compounds or elements gaining electrons. But if we flip the reactions around, flip this around to get this one, we can see that fluoride, which had been a product, is now a reactant, and it gives us fluorine and 2 electrons. Fluoride loses electrons. It's oxidized. Now, when it is oxidized, it has a E standard of actually negative 2.87. Recall that by flipping a reaction, we flip the sign of the E standard value. And so here, fluoride has a negative 2.87 voltage for its oxidation, whereas if we flip the very bottom one here, lithium, it has a positive E standard value of 3.05 voltage. And so we can see that that oxidation becomes actually more spontaneous as we go down because it has increasingly positive values. And so as you go down, you have increasing ability to be oxidized, or you have increasing strength as reducing agents. So what is a strong reducing agent? Or what is a stronger reducing agent? Fluorine, fluoride, lithium ion, or lithium. Which of these is the strongest reducing agent? Well, we know that as we go down, we have increasing strength as a reducing agent, but which of these is strongest? Lithium ion or lithium solid? Well, lithium ion gains an electron to turn into lithium solid. We see that it can be reduced, but to be a reducing agent, can it be oxidized? Well, can lithium ion be oxidized? Can it lose an electron? Well, no. That would give us Li2+, which you know is not stable at all. Can lithium ion be oxidized? No. This reaction does not occur. But can lithium solid be oxidized? Flip this reaction around. Lithium turns into Li plus and gives an electron. Does that reaction occur? Sure, you know that lithium ion can exist and is actually quite stable. Lithium solid, metallic lithium, is a very strong reducing agent. In fact, it's the strongest. Why is lithium, so that is our answer here, why is lithium a stronger oxidizing agent than all of these others, cesium, potassium, sodium, magnesium? Well, we don't need to go into the reasons there, although a lot has to do with ionization energies. But you might recall from the activity series that the highest thing on the activity series is lithium, much higher than things like potassium and sodium. And so the higher it is on the activity series, the more reactive it is as a metal, and hence also the stronger reducing agent it is. Thanks for watching, guys.